Whenever you enable the second level cache, you have the flexibility to choose the concurrency strategy for each and every entity that is cacheable. We have a handful of options available to choose from, and we need to choose the one that fits our needs. So let us try to explore all the list of options available. The first of which is read-only strategy. When you set the entity to read-only strategy, then that means we are sure that there won't be any updates on that entity in future. As an example, say that you're trying to store all the list of countries available in the world. So that table would have a couple of fields. One is the identifier and the other is the name of the country. It is very unlikely that somebody would change the name of the country, and so it's very unlikely that you want to make edits in the table. So it's safe to assume that we're going to perform only read-only operations on that table. That being said, we will be able to add the objects into the table and retrieve them, but not make any updates. In case if you're trying to make any updates on this entity, then Hibernate will throw an exception. That's because when Hibernate fetches the objects of this entity from the database and stores it in the second level cache, it stores it in such manner that we can't make any updates to it. And in here we have set the strategy to read only, and that means we can't perform any updates on our employee objects. If I try to do that, so in here I've just fetched the employee object and then I'm trying to make edits to it. Let us try to run this program and you would see an exception. And sure enough, we have an exception and that says can't update read-only object. So that explains. So clearly, in case of employee, this is not the strategy that we need to choose. So let us try to explore others and see which one fits in here. The second strategy is read-write, and this is apt in case if you're going to do a lot of updates in your table. This option also ensures data consistency when multiple transactions are trying to play with the same object. Let's say that you have a couple of transactions, T1 and T2, and they both are trying to access the same object. With this read-write strategy, the first transaction that gets the object will acquire a lock, and the other transaction cannot access its data in the cache, but rather it would access directly from the database. Thereby, it would get the latest data from the database. In case if this sounds confusing, then just keep in mind that when you're trying to make a lot of updates in your entity, then you want to use this strategy. And clearly, this is a strategy that we're going to use in case of our employee entity. Next comes the non-strict read-write, which is equivalent to read-write, but the difference is it does not really ensure any kind of data consistency. That's because in this case there won't be any locking mechanism, or the operations is performed in asynchronous manner, and so there is no surety of the data consistency. You want to use this strategy only when you know that you're going to make minimal amount of updates on the entity. And even in case of data inconsistency, you can cope with it. As an example, say that you have a table called address and you're storing all the addresses of employees. It's pretty rare that you want to make changes to that table because not very often everybody changes their address, and also it's very unlikely that couple of transactions want to make updates on the same employee object. But even if that happens, the data inconsistency shouldn't lead to a serious problem. But you may argue that to be safe, we better use the read-write strategy. Well, the answer is no. In some cases, this might be the ideal option because if you choose this strategy, then there is the additional overhead of ensuring the data consistency, and thereby it will degrade the performance a little bit. So you don't want to use this strategy unless you really need it. The last of which is the transactional strategy. This would come into picture when you're using JTA or Java Transaction API, which is one of the Java 2 Enterprise Edition specifications for managing the transactions. It's an optional thing that you can use with Hibernate. In case if you're using and you're performing a lot of transactions, then this might be the ideal option. So the data from the database would be fetched in such manner that it would be ideal for performing transactions. Otherwise, you can go with the other strategies. We also have one more strategy. It's not really a strategy, it's an option, and it is none. That means you're just simply disabling an entity from being part of the cache. You can see all the list of options in here, and here they are. Alright, see you soon.